Hi everyone, welcome to AI Crack channel. This is Akash Gangbar and today we'll be studying progressions lecture 5. In this lecture we'll be talking about AM, GM, HM inequalities and also we'll be talking about different types of summations. Okay. So let's begin our lecture with AM, GM, HM inequalities and we'll start with two numbers. Okay, we'll start with two numbers and then we'll extrapolate that for n numbers as well. Okay. So let's derive for two numbers and then we'll be using the same inequalities for n numbers as well. So we'll be having two cases, either all positive or all negative numbers, right? So let's start from two positive numbers, a and b. Both are actually positive, right? So am would be a plus b by 2, right? Gm would be root ab, right? Now if we talk about this expression, am minus gm, that would be a plus b by 2 minus root ab. If we take the LCM, we'll be getting a plus b minus 2 root ab divided by 2, right? Now this can be written as root a square plus root b square minus, okay, I'll write this over here. This is root a square plus root b square minus 2 root ab divided by 2, right? Now this actually becomes root a minus root b whole square by 2, right? Now you can see that this expression is always either positive or equals to 0. It can be 0 when a equals to b. Basically, when we have the equality of numbers, in that case, this term would be 0, or else it's always positive, right? So the first thing that we can conclude is am minus gm is always either equals to 0 or positive, right? So am greater than equals to gm for positive numbers, right? And now in the second case, if we talk about gm hm inequalities, we have same two numbers, both are positive, right? A and b. Now gm would be root ab, right? Hm would be 2ab upon a plus b, right? Now if we talk about gm minus hm, that would be root ab minus 2ab upon a plus b. Now let's take root ab as common. We'll be getting 1 minus 2 root ab upon a plus b. If we take the LCM, we'll be getting root ab multiplied by a plus b minus 2 root ab divided by a plus b, right? I can see that this again becomes root a minus root b whole square, right? We know that root ab is positive, a plus b is positive, and root a minus root b is either positive or 0. So again over here we have got this inequality, gm is bigger than equals to hm, right? We also know that am is bigger than equals to gm. So what we can conclude, am is bigger than equals to gm is bigger than equals to hm, and equality holds for a equals to b. When we have a equals to b, these three actually all are equal. Okay, now if we talk about the negative numbers, so let's take a similar case. Let's take minus a and minus b. Okay, a and b are positive, but we have taken minus a and minus b as numbers, so both have become negative numbers, right? So am would be minus times a plus b by 2, right? Gm would be minus root ab. We talked about this same thing, right? For negative numbers, gm is always negative root ab, right? So if we talk about am minus gm over here, that would be minus of a plus b by 2 minus root ab. And we talked about this in the previous example, that this term is always either positive or equals to 0. So with the negative sign outside, so this entire term actually becomes less than equals to 0, right? So for negative numbers, inequality changes. For positive numbers, inequality is this, and for negative numbers, inequality is this. So for negative numbers, we can conclude that am is less than equals to gm is less than equals to hm. Simple, right? Now you can extrapolate this for n numbers as well. Let's say if we have three numbers, a b c, all are positive, in that case as well this same inequality would hold, am bigger than equals to gm bigger than equals to hm. Okay, and now let's solve this question. If L, M, N are three positive roots of the equation x cube minus ax square plus bx minus 48 equals to 0, then the minimum value of 1 by L plus 2 by M plus 3 by N equals, right? Now, as of now, we are studying AM, GM, HM inequality. So that's why we know we have to apply that over here. But in the examination, we might not be knowing what we have to apply, right? So what should be the trigger point so that we can identify if we have to apply AM, GM, HM inequalities, right? So the first thing to understand over here is you have to identify these terms. minimum value, maximum value of summation, minimum value of product, maximum value of product. If these four types of statements are there, in that case, most likely we have to apply AM, GM, HM inequalities. Secondly, if all three are positive, basically if all numbers are positive, all numbers are negative, in that case, that should be your second trigger point to understand that we have to apply AM, GM, HM inequalities, right? So now that you have understood this, let's move forward with the question. Now in this question, we have LMN as three positive roots of this cubic equation, right? And because of this, because of theory of equations, we can say that product of roots, that is LMN, equals to minus of minus 48 by 1. That is 48, right? Now since we know the product, we can apply AM, GM inequality since all are positive, right? So we have to find out the minimum value of this term, this expression. So we'll be getting 1 upon L plus 2 upon M plus 3 upon N divided by 3 is bigger than equals to 1 upon L dot 2 upon M dot 3 upon N raised to power by 3. Now LMN is 48. So this actually becomes 6 upon 48. That is 1 by 8. 1 by 8 raised to power 1 by 3. So we have 1 upon L plus 2 upon M plus 3 upon N divided by 3. So this actually comes out to be 1 by 2. So this 3 goes over here. So this becomes 3 by 2. So 3 by 2 is the correct answer. Basically, the minimum value would be 3 by 2. It's always bigger than equals to 3 by 2. So the minimum value would be 3 by 2. And when these three terms are actually equal. Okay. And now let's solve this example. Minimum value of b plus c upon a plus c plus a upon b plus a plus b upon c for real positive numbers a, b, and c. Now you can see that we have minimum value and we have all positive numbers. So that's why we have got both the triggers that we have to apply AM, GM, HM inequalities over here, right? Now the given expression is b plus c upon a plus c plus a upon b plus a plus b upon c. Now, whenever you get stuck in such a situation, such an expression, try to create symmetry or try to find symmetry. In this case, we cannot find any symmetry, mathematical symmetry, we cannot find, right? So we have to create a mathematical symmetry over here. How can we do that? We can see that A is missing from here, we can see that B is missing from here, and we can see that C is missing from here in the numerator, right? So if we add 1 in all three numbers and subtract it over here, what will be getting? We'll be getting A plus B plus C by A plus a plus b plus c divided by b plus a plus b plus c by c minus 3, right? Now we can see that we have got a mathematical symmetry over here, right? So what we can do, we can take a plus b plus c multiplied by 1 upon a plus 1 upon b plus 1 upon c minus 3, right? Now you can see that this looks like something like HM and this looks like something like AM, right? So that gives us hint we have to use AM, HM inequalities, and I'll leave that for homework. You have to apply that, right? And now let's solve this example. If A, B, C belongs to R plus such that A plus B plus C equals to 18, then the maximum value of A square B cube series per 4 is equals to, right? So we have this R plus over here, we have this maximum value over here. So we have enough triggers that we have to apply AM, GM, HM inequalities, right? Now, until now, when given with this condition, A plus B plus C equals to 18, we could find out the maximum value of ABC, right? With the help of AMGM, right? A plus B plus C divided by 3 is bigger than equals to ABC raised power 1 by 3, right? With the help of this one, we could find out the maximum value of ABC, right? But what about this A square B cube C4? We don't have two A's, we don't have three B's, we don't have four C's, right? So if we don't have, we can create it. How? We can write A as A by 2 plus A by 2. Similarly, we can write B as B by 3 plus B by 3 plus B by 3. We can write C as C by 4 plus C by 4 plus C by 4 plus C by 4 equals to 18. Now these all numbers are positive because A, B, C individually are positive, right? So these all numbers are positive. Now we can apply AM, GM inequality over here to find out the maximum value of this product. But here's the catch. Why are we not using 2A by 3 and A by 3, right? Why don't we do that? So let's take one example for that. Let's say we have two numbers x plus y and the summation is 10. So x, y can take multiple values over here, right? So let's say x equals to 6 and y equals to 4. And for one more case, let's say x equals to 5 and y equals to 5. Now in this case, product would be 24. In this case, product would be 25. I can see that when we are taking the equal values, product is maximizing. And we have to find out the maximum value of product, right? So that's why we have divided terms into equal parts. Okay. So what we can do, we can write this as a by 2 plus a by 2 plus b by 3 plus b by 3 plus b by 3 plus c by 4 plus c by 4 plus c by 4 plus c by 4 divided by 9, right? Because this is 4 plus 3 plus 2, that is 9. That is bigger than equals to, we'll be getting a by 2 whole square dot b by 3 whole cube dot c by 4 raised by 4 raised to power 1 by 9. Now you have got these powers. After that you can solve it. Take that as homework. Okay. And now let's revisit different types of summations. And in the previous lectures, we talked about sigma n equals to n plus 1 by 2. Sigma n square equals to n plus 1, 2n plus 1 by 6. Sigma n cube equals to n plus 1 by 2 whole square, right? So now let's explore this further. So sigma n square is nothing but 1 square plus 2 square plus 3 square plus 4 square plus 5 square till n square, right? Now this first term is at first position, this one at second, this one is third, this one at fourth, this one at fifth, and this one at nth position, right? So what do we mean by that? The value of this particular term is dependent on the position, right? Value of this particular term is also dependent on this position. So value of any term in this series is dependent on its position, right? So if n equals to 5, then the term is 5 square. If n equals to 6, then the term is 6 square, right? So in general, for any term n, we can say that general term is n square. This is what we mean by this n square, right? This is just a general term. Now let's say if I have sigma n square plus n plus 1 whole square, right? Now in that case, we'll be having 1 square plus 2 square. This is our first term. Second term would be 2 square plus 3 square. Third term would be 3 square plus 4 square, right? Again, every term is dependent on its position. That is n square plus n plus 1 whole square. Now, is there a way we can find out this summation with a formula, right? Until now, we have talked about just sigma n square, sigma n cube. But can we find out this particular summation? Can we do it? So for that, let's see these properties. So the first property is sigma k times n equals to k times sigma n, right? So let's say if we have Tn equals to, let's say 2n, right? So we have to find out sigma Tn, that is sigma 2n. That would be 2 times sigma n. That comes out as 2 into n plus 1 by 2. We have to use this formula like this, right? Now if we talk about the second case, in second case, basically it's saying we can split out terms. We can split this sigma for these individual terms over here. So if Tn equals to n plus n square, then sigma Tn would be sigma n plus n square. That would be sigma n plus sigma n square. Now this comes out as n plus 1 by 2, and this comes out as n plus 1, 2n plus 1 by 6, right? So this is how we have to use this particular property. Now third property is nothing but the application of first and second together in the third one, right? Simple. And now let's solve this example. Find the sum of n terms of the series 1, 1 plus 2, 1 plus 2 plus 3, and so on, right? So the first thing to do over here is we have to find Tn, and secondly, we have to find sigma Tn, okay? Now let's first talk about Tn over here. You can see that the first term is 1, second term is 1 plus 2, third term is 1 plus 2 plus 3, fourth term would be 1 plus 2 plus 3 plus 4, and similarly, nth term would be 1 plus 2 plus 3 plus 4 plus 5 till n, right? Now you can see that nth term is nothing but sigma n, right? What is sigma n? Tn equals to sigma n equals to n plus 1 by 2. That comes out as 1 by 2 times n square plus n, okay? Now we have got Tn, so we have to find sigma Tn, right? That would be sigma 1 by 2 n square plus n. Now we can use the property, we can take this constant outside. We're getting 1 by 2 sigma n square plus n. Now this becomes 1 by 2 sigma n square plus sigma n, right? Now this becomes 1 by 2 n plus 1, 2n plus 1 by 6, and this becomes n plus 1 by 2. So this is our answer. You can solve this further. This is our answer, okay? And now let's talk about method of difference. So until now, we were able to figure out what is Tn, and then we were doing sigma Tn to find out our answer. So the main thing over here is we were able to figure out what is Tn, right? But there can be certain cases where we might not be able to figure out what is Tn, right? So let's say we have a series A1, A2, A3, A4, A5, A6, and A7, right? And we can see that this is not an AP, this is not a GP, this is not an AGP, and we're not able to figure out Tn. of this particular series. So what we'll do, we'll start taking differences of consecutive terms, right? So let's say we've got a series of differences, that is d1, d2, d3, d4, d5, d6, right? Now one thing we'll define, that is level. So for first set of differences, we have defined level lambda equals to 1, right? Now let's say this d1, d2, d3, d4, d5 also is not an AP, GP, and we are not able to figure out what is Tn. So we'll take one more set of difference of consecutive terms, and let's say we're getting d1, d2, d3, d4, and d5 all in capital. Okay. Now over here lambda would be 2 because this was the second set of difference, right? So now you understand that how are we defining lambda. So we are defining lambda based on the level of differences, right? So in this case, this was the first set of difference, that's why lambda was 1. In this case, this was the second set of difference, that's why lambda was 2. In case there is a third possibility of taking a difference, in that case lambda would be 3. So lambda is defined as level over here, right? Now once we have defined lambda, now we'll either get the differences as AP or GP, right? So whatever the differences we have got at a particular lambda, they'll be either in AP or GP, right? So let's take the first case when differences are in AP. Okay. Now let's say lambda equals to 1 over here, or let's say 2. Okay. Now in that case, what will happen? Tn would be a function of n, where this function of n is nothing but a degree of lambda plus 1, polynomial of degree lambda plus 1. Okay. So for example, lambda equals to 1. In that case, Tn would be an square plus bn plus c. That is a polynomial of degree lambda plus 1. Lambda is what? Lambda is 1. So that's why degree is 2. So this polynomial is having degree 2, right? Now, let's say the case is difference of consecutive terms is in GP. In that case, Tn would be defined as some constant multiplied by r of that GP, common ratio of that GP, raised by n minus 1, plus function in terms of n with a degree lambda minus 1. So let's say if lambda equals to 2 over here. Okay. In that case, Tn would be ar raised by n minus 1 plus an plus b. This is a linear polynomial of degree 1, right? Because we have lambda equals to 2, so degree should be 1. So this is a linear polynomial of degree 1. Okay. So this is how you have to define Tn, and then you have to find out Tn, sigma Tn. Okay. And now let's solve this example. Find the sum to n terms 3 plus 7 plus 13 plus 21 plus 31. Okay. So if we take the difference of the first two terms, we'll be getting 4. For these two terms, we'll be getting 6. For these two terms, we'll be getting 8. For these two terms, we'll be getting 10. Right. Now you can see that we have got an AP 4, 6, 8, 10. So lambda should be 1. Why? Because right after the first set of differences, we have got an AP. Okay. So according to a rule, Tn should be a function of n of degree lambda plus 1. That is 2. Right? Lambda equals to 1. So that's why degree should be 2. Okay. So Tn would be what? An square plus bn plus c. So this is how our Tn should look like. But we still don't know what is a, b, and c. Right? We have to find out these variables. To do that, we'll be doing one simple thing. So our Tn over here is an square plus bn plus c, right? Now we know that t1 is 3, right? So if we put 1 over here, we'll be getting 3 equals to a plus b plus c, right? Now t2 equals to 7. So if you put n equals to 2 over here, we'll be getting 7 equals to 4a plus 2b plus c. Similarly, t3 equals to 13. So if you put n equals to 3 over here, we'll be getting 13 equals to 9a plus 3b plus c. Now we have got three equations, three variables. You have to find out a, b, and c. Once you have got a, b, and c, then you'll be able to figure out what is Tn, right? And once you know, figure out. And now let's solve this example. Find the sum to n terms 1 plus 4 plus 10 plus 22 plus 46, right? And let's keep this as homework because this is a similar kind of problem. Over here, you'll get differences as GP, right? So you have to use the other formula over here, okay? So today's lecture was till here only, and this was the last lecture of progression. So we are done with progressions over here. So let's meet in the next lecture for binomial. Thanks for watching.